Hello viewers, thank you so much for all the love and care given in the first episode. Now we are back with the second episode and it is a very technical yet a very fancy topic on SWAS system. To simplify it, we have Mr. Parthik Gajjar. He is the business unit head for water and liquid. So I welcome you Mr. Parthik Gajjar. Welcome Parthik bhai on the show.
Thank you, Arshil.
Parthik bhai, I would like to directly start on the topic. Let's keep it simple. We will start with what is SWAS system.
Okay, it's a good question, Arshil, by the way. And basically, the SWAS stands for the Steam and Water Analysis System. It's used for the mostly power plant boiler application to make the run of the power plant and boiler safe and reliable. It's basically for the continuous monitoring of the impurities and chemicals for the boiler steam and water analysis system. That's called the SWAS steam and water analysis system.
So you talked about impurities, steam, water. So basically, where is SWAS mainly used?
Major application of SWAS is each power plants, because at every power plant there is a boiler who can convert the water into the steam, and that steam we are giving to the boiler turbine blade. So before going any steam or any water to the turbine blade, we have to check the impurities. If there is some of the impurities are there, it will damage the blade of the turbine. So that is the major critical system for SWAS for every power plants.
So when we talk about power plants, and it is involving water, steam, turbine, boiler, the major impurities are also being in the water or steam.
Water.
So what are the different typical measurements or typical systems being monitored by SWAS?
Okay, if I call about some of the parameters, so like parameters like pH, conductivity, silica, sodium, phosphate, hydrogen, that all the major parameters. Mineral oxygen are also the major parameters we need to monitor before applying any steam or water into the turbine blade.
So you talked about power plant and you talked about SWAS as a DO in the power plant.
Right.
So where exactly is SWAS installed in the plant?
Okay. So there is SWAS, we can install it near to the boiler room. In every boiler there is a SWAS rooms are there. We are taking the samples from the boiler that we are giving to the wet rack of the SWAS panel, and there is also dry panel available where we are going to install the transmitter or analyzers for each SWAS system.
So we are talking about the dry and wet panel. So these are basically the conditioning systems, right? So what is the main role of the conditioning system in the SWAS system?
It's a really good question and it's a lovely topic for me because I started my career from the SWAS only. So when I joined the Axis Solutions, I am handling all the project for the execution of steam and water analysis system. Yes, so basically the sampling system is must required for the SWAS system. That is the core heart of the SWAS system. Because what happened if we are asking for the boilers? So what is the boiler? There is a high temperature, high pressure. So the analyzer cannot withstand that much amount of the high temperature and high pressure. So by default we have to cool down the temperature, we have to reduce the pressure. So exactly the sampling system doing the same things for the SWAS. There is some components we are using, like sample cooler we are using to reduce the temperature for any of the steam of the SWAS. There is different multiple steams, like feed water is there, economizer is there, boiler water is there, superheated steamer, saturated steamer is there. So there is every steam there is different temperature. Some steam have 300 degree temperature, 400 degree, 500, 350 bar pressure. That much amount of high pressure are there into the boiler steam. So that we have to definitely reduce. So that's why we have to use the sample handling system. And the advantage with us that the sample handling system as well as the components that is manufactured by the Axis. So that we have a core technical fields, our core technical engineers who are continuously doing research for their components and we are using for the SWAS system.
Oh, that is really great when we talk about Axis being manufacturing its own components and it is used in highly reliable or high-end flammable or hazardous area like power plants. So when we talk about system, it is made of components, right? So can you tell the viewers how these SWAS components are being fixed and how it is being converted into a system?
Okay. That is the good question, Arshit. The components which you are asking to access have divided the product components into some of the verticals. We have given the brand name. So like that, if I talk about the SWAS, so for my viewers, the axis given the brand name as a Bashpa for the SWAS product vertical. So that Bashpa is basically the name, Sanskrit name of the steam. So from that we are using that name for our product basket also. And the main basic components are like sample cooler, which we are using to reduce the temperature. Pressure reducing element APRV, variable pressure reducing element, for reduce the high pressure to the low pressure. Then we have back pressure regulator for the safety of the pressure. If the APRV fails, then high must the main sample stream pressure of 350 bar, 400 bar cannot go direct to the analyzers. So for the safety of pressure, we are using the back pressure regulator. Then we have a seminal auto shut-off valve for the temperature safety. If sample cooler fails, then high temperature amount of the sample cannot pass to the analyzer. So for the safety of analyzers, we are using these two components for pressure and temperature safety. Then we have fat flow indicators, which we are using to check the continuous flow of the cooling water line. Then we have a strainer also who can do the filter works for all the SWAS systems. So like that, was multiple components we are manufacturing by our own and we are using for the SWAS sampling system. And specific, there is one important parameter called the conductivity. So for the conductivity measurements, we have to remove some impurities into the water. So for that, we have a cation column. Advanced version of cation column we have where we are using the resins filling into inside the cation column for the measurement of the cation conductivity.
That's very deep actually. When we talk about a SWAS system and the components are being made, so as I have rightly counted, there are around 23, 24 components you name. But for viewers, they might be not very technical. So in a very layman term, what should we talk about SWAS and the system and the components? How can it be defined in a very simplest way, Parthik bhai?
So it's the simplest way if I talk. So there is a SWAS is basically, or as I already mentioned, it's checking the impurities and purities of steam and water. So in shortest way, if I summarize it, the SWAS is basically to check the impurities and purities of steam and water before applying to the turbine plates. And it is measuring some of the purities, impurities like pH, conductivity, silica, sodium, phosphate, who can affecting the turbine plates. And that high temperature and high pressure line, we are using the sample conditioning system to reduce the high pressure and the high temperature. So that's called the entire SWAS steam and water analysis system.
Understood. So that is very great actually. The brand name is taken by the local roots, that is from the Sanskrit term. So and actually when we talk about Axis is following the legacy of Make in India and Think Global, Act Local policy, right? So we have been talking about a lot of technical terms and we have talked about systems, we have talked about products, we have talked about brand names. So when we talk about this SWAS system being installed or commissioned in a power plant, so after installation, how it increases the reliability of a power plant?
Okay. So as I mentioned, if we are not putting the SWAS system, so we have no idea that what are the impurities going into the water and steam to the turbine plates. What happens sometimes, it will clog the boiler's tube also. If there is a high amount of silica, high amount of conductivity and all. So it will clog the boiler tubes also. It will, due to the corrosion effect, it will damage the blade of the turbine. So there is a maintenance of that boiler, particularly boiler or particularly turbine. It's very difficult. If any power plants, if you need to shut down, that's a very critical due to this effect of the damages into the turbines and turbine blade. So that's why what we are using nowadays, we are putting the SWAS system before giving any steam and water analysis or any steam and water into the boiler blade or turbine blade. We are measuring all the purities and impurities. So that's why predictive maintenance we can do. So that's why there is a major advantage of the SWAS system. And there is some following guidelines are there that compulsory we have to follow. By there is some power plant ASTM guidelines are there. Yes, ASTM D106, D1192 guidelines are there. There is EPRA guideline, IS Indian standard guidelines are there. That we have to follow for each power plant. and they have must need to install the SWAS system.
So we have talked about the guidelines, we have talked about the system components, so on. So when we talk about steam and water analysis as a system, what are the different types of SWAS systems that are being customized as per the requirements?
So according to that, we have some different component systems that we are designing for the SWAS system. So one is for some of the single application. If we are measuring, so we have a single line SWAS system that can only measure like some UOP plants, balance of some of the plants that require only the measurement of the single parameters. So for that we have a single line SWAS system. For exact boiler application, where the boiler has 6 or 7 streams like feed water, economizer, superheated, saturated, blowdown water. So for that we have multi-stream SWAS system where we are providing the separate dry rack and the wet panel we are providing the separate. Then the one advantage is access being into the oil and gas from the long. So some of the applications we require the walk-through shelter type. So there is no space available, RCC space not available near to the boiler room. So what we are providing the shelters, and we are installing the entire SWAS system inside the shelters. So that is the main advantage, that walk-through analysis shelter type also we are using.
So as I understand it is customized based on the requirement of the client.
Yes,
right?
exactly. It's application-wise totally customized. Even we are giving the designing to our customers or our viewers. If there is some specific, they have challenges for the storage. They don't have any boiler, one control room over here to the boiler area. So that's why we are providing some e-houses. We are giving the shelter. So that spaces also we are providing to the customers.
So to the viewers, Axis Solutions provide end-to-end support from designing to installation to commissioning to after-sales support and the AMC CAMC. So when we talk about Axis as a company being into oil and gas market since more than 25 years, right?
That's right.
So how Axis SWAS system is different from others? SWAS system.
So nowadays there is basically the standard rules for the designing of the SWAS. I mentioned some ASTM guidelines and all that need to follow by the everyone. So but now what we are doing, now the generation is going towards the AI side. So that advantage we are taking nowadays, we have designed the smart SWAS. So we are installing some AI based sensors over to the SWAS system. We are taking some feedbacks from them and we are giving the predictive maintenance to our customers. And now this time is coming, now you have to calibrate your sensor. Now there is a time you have to replace your mechanical components. Now your pressure is going to increase. Now your pressure component is not working. Temperature component is not working. So the AI is predictive now we are giving. And we have designed an IoT software also, where we are taking all the data of the SWAS and then we are giving to the customer. So it's easy access. If you are installing the SWAS, you can install it in your mobile. That app you can install in your mobile and you can see what happens to your power plants. Also the advanced version.
So that is a scalability point of view which we are talking about. It is the future. Smart is the new future, right? So thank you so much, Parthik bhai, for joining in and simplifying this very typical yet fancy topic.
Thank you, Arshil, to giving the opportunity to explain about the SWAS. It's a really very high topic. We can talk multiple hours on this, but whatever I try my best to convince on the summary point. Thank you, Arshil.
Thank you, viewers, for joining in. I hope you would have liked the show. Thank you so much, Parthik bhai, for simplifying this typical yet important topic in a very simplest way. I would like all the viewers to keep showering your love as you have given us in the first episode. I would also request you to keep supporting us by liking this, sharing this podcast, commenting on the same, and also subscribe to our YouTube channel. Thank you so much.